Hey everybody, welcome back to Code with Vinny. Today we're going to be talking about asynchronous code in JavaScript. Asynchronous code can be kind of a tricky topic when you're first starting out. I know I had a little bit of trouble with it, but once you kind of understand why it exists and what's happening, it's actually not that bad. So let's go ahead and get right into it. Well, you're probably asking yourself, why do we need asynchronous code in the first place? Well, it's because JavaScript is a single-threaded programming language. And basically what that means is we're only able to execute a single sequence of operations at a time. In other words, we can't do two things at once. And oftentimes we run into certain tasks that take a really long time to complete. If we don't use asynchronous code to handle these tasks, then our application would essentially freeze while we're waiting for this job to be finished. If we use asynchronous code, we can run other operations in the meantime and come back to our asynchronous code later so our application isn't stuck in this frozen state. This makes our application more performant and provides a better user experience. So the most common places you would see asynchronous code is when you're fetching data from an API, doing file operations, or even user interactions. In my opinion though, fetching data from an API is definitely the most common, and that's what we're going to be focusing on later in this video. The next important concept you need to understand when dealing with asynchronous code is promises. A promise is an object representing the eventual completion or failure of an asynchronous operation. And the way I like to think of a promise is an object that essentially promises us that it's going to respond to us eventually. And it's important to know that a promise has three potential states, and that's pending, fulfilled, or rejected. Pending meaning the operation still isn't completed, fulfilled means that the operation has completed successfully, and rejected meaning it tried running the operation but it failed at some point. Promises are really important when dealing with asynchronous code because it allows us to use things like async await and promise chaining. With that being said, let's dive into the code. So all this code is doing is using a library called Axios to send a GET request to this API that essentially sends us fake to do data. And we're storing that response in this variable and printing it out. So if I run this code, you can see that we're not actually logging the to-do like we want. We're logging the promise in its pending state. Like I said earlier, promises have three different states: pending, fulfilled, and rejected. So at the time of us running this console log, the promise was in its pending state. And the promise doesn't have much value to us when it's in this pending state. We want to wait for it to be fulfilled. So there are two different ways we can make sure that the promise is resolved before we deal with any of the information that it's going to give us. The first way is by using promise chaining, and the second way is by using async await. So I'm going to go ahead and get rid of all of this. We're not going to need it anymore. And I have an example of promise chaining right here. So this function right here is an example of a promise chain. As you can see, we're using these methods like .then and .catch that essentially allow us to handle the data that the promise is giving us depending on whether or not the promise was fulfilled or rejected. Basically, if the promise was fulfilled or it succeeded, then we're going to use this .then block. And if the promise failed or it was rejected, then we're going to run the code inside the catch block. So both .then and .catch take in callback functions, and the first parameter that's passed into those callback functions is the response that our promise is giving us. So because we're doing a GET request, the response object has a bunch of information on it like the status code, but the only thing we really care about is the data, so that's why I'm doing response.data. So if our promise is successful, we should log a to-do right here, and if it's not successful, then we should log the error. So I'm just going to go ahead and run this function, and we're going to see what happens. So you can see we have successfully logged our to-do. That means we hit our .then block. Now let's go ahead and try to hit our catch block if the promise doesn't succeed. So if I open this up, you can see we get this giant object with a bunch of error messages and things like that. But essentially, the important concept to understand is .then handles success and .catch handles errors. Now the other technique we can use to handling promises is called async await, and this is actually my personal favorite. Promise chaining can just get a little sloppy sometimes when you have a lot of promises back to back, because then you have to dot then, dot then, dot then, and it gets pretty out of hand quickly. But when using async await, the code oftentimes is a lot more readable and easier to understand. So it's important to know that these two functions are doing the same exact thing, it's just different ways of handling it. When using async await, you need to use the async keyword before the function declaration, and you have to use the wait keyword before any of the asynchronous code. So because we have the wait keyword before our API request right here, we can store the response in a variable just like we would with normal code. And if you remember earlier, I showed you an example of us running this exact line of code without async await, and that's when we got the promise in pending status. But now that we use async await, we actually wait till the promise is fulfilled before storing that value in response. Another important thing to note is that we have to use a try and catch block when using async await, because we still have the potential of the promise getting rejected. So basically, if there's any errors within this try block, it's going to be caught right here where we can log it out instead of just breaking. Now let's go ahead and run this function just to make sure it's going to work. And as you can see, we're getting our response back just like we want. The only difference is we didn't do .data this time, so let me go and fix that real quick. Now these functions do the exact same thing, but that's really all there is to it when it comes to handling asynchronous code and promises in JavaScript using promise chaining and async await. If you enjoyed this video, please like and subscribe. Thank you so much for watching, and I'll see you in the next video.